So we'll start with the domains, domain and range of various functions. Domains and range of various functions. So I'm picking from very different papers. Okay, so we'll start with this one. The examples. 1, let f of x be equal to 25 over 3x minus 2 and g of x be equal to simple x plus 1. 1, find the domain and range of f. 2, find the inverse function of f. 3, solve f of g of x is equal to 2 over x minus 1. So I might have done this question at some point, but we may do it in a different way today in answering it, especially the first part there. Part 1, find the domain and range of f. So remember that the domain is just the same thing as being asked to find the vertical asymptotes, and then you remove them from the set of real numbers. So we get 3x minus 2 and equate it to 0. And then solve for x, we get 2 over 3. This is the vertical asymptote. This is the vertical asymptote. The vertical asymptote, remember, it has never been touched by the curve, by the graph. The only thing you can think of touching maybe is the horizontal asymptote, but not the vertical. So the domain of f becomes the whole set of real numbers except for this value of x, 2 over 3. So to say except, you write x is not equal to 2 over 3. So x a real number such that x is not equal to 2 over 3. We go for the range. The range, you simply get the horizontal asymptote. In this case, the horizontal asymptote, because the numerator variable has a degree lower than the denominator variable, so because of the difference in the powers, we are saying the horizontal asymptote is a line y is equal to 0. Or you get the limit as agreed as x goes to infinity of 25 over 3x minus 2. How do you get the limit? You simply say this is the limit as x goes to infinity. Factor out the highest degree in the denominator, and you have 3 minus 2 over x. And then on top, you get the same x that is coming from down, factor it out. So because there was no x, then you write 25 over x so that you don't change anything there. So this x down takes away the x that is up so that we have the limit as x goes to infinity of 25 over x over 3 minus 2 over x. So we want this so that we use the fact that as the limit as x goes to infinity of n number over the variable x to n power gives 0. So that this top one becomes 0 and this one becomes 0. Then we'll have 0 over the number 3, which makes the whole thing 0. Because the horizontal asymptote is 0, then the range of f is y a real number such that y is just not equal to 0. That is how you get the range. Hello.
I'm very behind on how you use the limits to find the range in yeah. I'm kind of asking if you can explain a bit. I know that formula of comparing the what the highest degree of x.
All right. So that formula gives y is equal to 0, is it?
Yes.
Okay, and the limit has given us y is equal to 0. So then how do we get to use the limit? So we're saying we start from here. We've got this fact here in this course. This is not proved, but we use it. So whenever I have a constant on top and a variable x in the denominator, and I'm looking for the limit as x blows off to infinity, it will always be getting to 0. Okay, so in most cases, whenever you find yourself dealing with a limit as x goes to infinity, you always want to find a way of getting to this so that you can use it. And how do we get to that? You look at the highest degree in the denominator, not in the numerator. So in this case, we have 3x minus 2. We can only see one x here, meaning that x to the power 1 is the highest degree in the denominator. So what do? We factor it out. Okay. In other words, we divide throughout by x as we keep it outside in the denominator. So when you divide by x, you get 3 minus 2 over x. And then you do the same in the numerator, taking the same x coming from the denominator, you take it up and then divide it again. So 25 over x. You don't simplify the numerator alone. You cancel this x with the x that is down. Then now we remain with the limit as x goes to infinity of 25 over x over 3 minus 2 over x. And what happens? We get back to the fact that we are looking for. We wanted to use this. We now have space to use it. 25 over x as x goes to infinity gives us 0. While 3 still remains 3. 2 over x as x goes to infinity gives us 0. Eventually, we have 0 over 3, which just becomes 0. That limit we find becomes the horizontal asymptote. The horizontal asymptote is what we exclude from the whole set of real numbers for us to have a range of a given function.
Wow, this is nice. What if it was in form of a quadratic?
Even if it's a quadratic. Suppose we had a quadratic, f of x is equal to 3x plus 1 over 4x squared minus 2x plus 3. You want to find the limit as x goes to infinity of the function f of x, which we write here, 4x squared minus 2x plus 3. What do? You say, okay, the limit as x goes to infinity, and then you factor out x squared because that's the highest degree in the denominator. So factor out x squared and then divide through by x squared. So we have 4 minus 2 over x plus 3 over x squared. You do the same on top. You take the very x squared. So you have 3 over x plus 1 over x squared. Then now we know this and this can cancel. Then we have the limit as x goes to infinity, 3 over x plus 1 over x squared over 4 minus 2 over x plus 3 over x squared. The limit behaves in this way. You can actually split it. The limit as x goes to infinity, you get for the numerator. And then you come down and have the limit and get for the denominator. What else does it do? It actually separates those. The limit as x goes to infinity of 3 over x plus the limit as x goes to infinity of 1 over x squared over the limit as x goes to infinity of 4 minus the limit as x goes to infinity of 2 over x plus the limit as x goes to infinity of 3 over x squared. So as we apply that property, we now have 0 for this part, 0 for this part. So we get 0 in the numerator over, we get 4 minus 0 plus 0, which becomes 0 over 4, which is equal to 0. Here is the reason why we go for the denominator. We are trying to avoid having zeros throughout. Okay, if we went for the numerator, we would have gotten something like, if we use the x in the numerator, we are going to have x and then 3 plus 1 over x. And then down it would become 4x minus 2 plus 3 over x. So it becomes, you still can't, this can still make sense. Because when you start pressing the limit, you have the limit on top, you have infinite on top, you have infinite down. Okay, of course, you put 1 here because you're factoring out. But this won't help us. And then we also try by all means to avoid a 0 here. That's why we pick the highest, because we know once we separate it from its constant, that constant will remain and it will have zeros throughout. Then our work becomes very, very nice. Mangara?
Sir,
Yes.
that statement you stated that when a over x will be equals to 0, how can you state it in this form? Because there's x, there's 3 over x, and there's that one which has a squared down. How can you use that statement when when using a quadratic. Here you have said the limit to be when x goes to infinity to be 2 over x, and when the limit of x goes to infinity to be 3 over x squared. So how can you use that statement where a is over x is equals to 0? Because we have two things here.
So at each point, when we separate it like this, at each point, we're having the limit as x goes to infinity, a over x to the power n. So here our a is 3. Let me use a pointer. So here our a is 3 and x n is 1. Here our a is 1, x n is 2. Here our a is 3, x n is 2. Here our a is 2, x n is 1. Here we just have a. If we went down, we'll have x n is 0. So that's why it's not appearing down. So we still apply it.
Okay, thank you.
Okay. So that's how you use it. Because once I have that limit, then it becomes the horizontal asymptote. Then I exclude it to form the range. Remember, the domain is the vertical asymptote that you are removing from the real line. The range is the horizontal asymptote that you remove from the real line. You do that every time. Now let's advance. We go to the inverse function of f. So we have the function f as our part 2 is equal to 25 over a 3x minus 2. We want to find the inverse. So to find the inverse, you let y be f of x.
Excuse me.
Hello.
Can you please go back to the previous slide that you're from? All right, thank you.
So we let y be equal to f of x. And then because we know what f of x, this will imply that y is equal to 25 over a 3x minus 2 over 1. Then we cross multiply. We have y 3x minus 2 is equal to 25. Remember, we're making x a subject here. So we expand throughout. I will have 3xy minus 2y is equal to 25. Then take this the other side. We'll get 3xy is equal to 25 plus 2y. Divide by 3y, divide by 3y. So we get x is equal to 25 plus 2y over 3y. What does it mean? It means f inverse of x is equal to 25 plus 2x over 3x. This is the inverse. To make x a subject, you first let y be the whole function, then you start solving for x. Then once you get x, you replace x by f inverse of x, and then you replace y by x. So this is a bit easy. Every one of us, we must be able to get that one. Then the third one is, I think this is a bit confusing most times. Solve f of g of x is equal to 2 over x minus 1. Oh yeah, we're recording the class, don't worry. So f of g is equal to 2 over x minus 1. I think in test 1, there was a question, something like g of f of some number, I think 4. I think that was the number. The question was very easy. You have two ways. You first find g of f, then substitute 4. Or you substitute 4 in f, then substitute that number in g. And that so many marks. Like, wasn't it 4 marks? Yeah, 4 marks. This should be a bonus because I just asked to substitute a number 4 in the given function. Okay, so in this case, how do we use it? So f of g of x is equal to 2 over x minus 1. First thing is we must have f of g. We must have f of g of x. This is f of g of x. And look, if you don't trust yourself, if you make a lot of mistakes, it's better you write this, because writing this carries 1 mark. Because you understand that it is g that is going inside f and not the other way around. So if you feel I can make mistakes here or I'm under pressure, you better write these steps so that where you lose it, at least you would have accumulated some marks. So now we substitute in the function f, we substitute g. So we have 25 over 3g minus 2. And remember, we know what g is. What is g? G is x plus 1. So you have 3 open brackets and you put x plus 1. Close minus 2. The mistake that is very painful when you get your paper is where you see things like someone writes 25 over 3 and then x plus 1 minus 2. And then you continue solving going down. This becomes wrong. Your solution will be wrong. So you put the brackets every time you are dealing with such multiplications. Then now we get 25 over 3x plus 3 minus 2. This is 25 over 3x plus 1. This is f of g. Okay, we're not done. We get back to the question now. F of g is equal to the right-hand side. We now have the f of g to equate to 2 over x minus 1. So we say, therefore, f of g of x is equal to 2 over x minus 1 implies that we have 25 over 3x plus 1 is equal to 2 over x minus 1. We now have an equation to solve. This is a normal equation. So you cross multiply, we'll have 25 open x minus 1 is equal to 2 open 3x plus 1, which gives us 25x minus 25 is equal to 6x plus 2. So we have 25x minus 6x is equal to 2 plus 27. So this is 19x is equal to 29. So x is equal to 29 over 19. Whenever you're asked to solve an equation, you're asked to find the variable x at all times.
Sir,
Hello.
it's supposed to be 25, this one.
Not 29.
Here where you say 25x minus 6x, then you took that 25 to the other side. That's negative 25.
Oh
It is
yeah.
positive 25.
Then so it's like I added when I was taking it. Like I get, thank you. So this is 25. 20. 25, yeah. so that this becomes 27. So you have x is equal to 27 over 19. Okay, so this becomes our solution. So the examiner may also ask you something like solve f inverse of x is equal to 2 over x minus 1. So now you know what you're bringing here is the inverse that you have found. And then you equate it to 2 over x minus 1 and you find the values of x. Okay, what more do we expect on the domains? Question 2, find the domain and range of 1 f of x is equal to the root of x plus 3 2 f of x is equal to the absolute value of 3x minus 7, and then 3 f of x is equal to the root of 3x plus 2 over x minus 4. Solution. So for the first one, the domain of f, well, you just go inside and get x plus 3 and make sure that it is always greater or equal to 0. Because the root, whenever you have the square root of a negative number, you don't know what to get. What you get is complex, and complex is not a real number. Complex numbers are not real numbers. Okay? Not all complex numbers are real numbers, especially this part, which is the imaginary. The imaginary is never a real number. So to avoid the imaginary numbers, you make sure that the inside of the root is greater or equal to 0. This now becomes an inequality where you say x is greater or equal to negative 3. So you get here and say the domain is x, all real numbers, but this x has to be greater or equal to negative 3, like this. Then the range, well, the range of these type of functions, like the radical, f of x is equal to the root, you just check the outside. Is it positive or minus? If it is positive the way it is right now, then you write 0 to positive infinity. So once I have f of x is equal to the root, that is positive outside. Aliza? So if it was negative, then you write negative infinity up to 0. In a general case, if you had f of x is equal to some number a plus the root of bx plus c, and you're asked to find the range, then the range, if you have a plus here, the range is always going to be a to positive infinity. If I have a plus there. If I have a minus, then the range is going to be negative infinity up to a. These are the general cases. And if a is not there, like it is in part 1, then we know that a is 0 there. So we don't get to be bothered. We just place the 0 there. Part 2. absolute value functions, the domain, even if you don't check the numbers involved there, for as long as it's absolute value function, the modulus, the domain is always all real numbers. Full stop. Always. Then the range again, you go inside and get 3x minus 7 equated to 0. So for x is 7 over, is it? No, not for the range. So that is supposed to be for a starting point. The range, you just look at the cases of a radical. So if there's no number outside, then you know it's from 0 to positive infinity. If it is positive outside. If it is negative outside, then you say from negative infinity to 0. But the general cases are these. F of x is equal to a plus the absolute of bx plus c. Then you say the range is from a to positive infinity. If you have f of x is equal to a minus the absolute value of bx plus c, then the range is equal to negative infinity to a. These are the general cases for these two types of functions. And it's easy to keep. Nothing hard there. Then the third one, well, we already know of the numerator that we cannot allow anything that is less than 0. So 3x plus 2 should be greater or equal to 0. Simply saying x must be greater or equal to negative 2 over 3. And the denominator, x minus 4, should not be equal to 0. So we get x is equal to 4. So we put together those two, say the domain of f is x, a real number, but we make sure that x is not 4. And again, x must be greater or equal to negative 2 over 3. So you put all the restrictions that you have accumulated, you put them together. And then, because of the denominator, which is x minus 4, this number can give you negative, it can give you positives. And the numerator can only give you positives. So because of the denominator, the range is then allowed to be anything. It can be 0 when the numerator is 0. It can be negative when the denominator is negative. It can be positive when the denominator is positive. So we say the range here is, the range of f is all real, because of the flexibility of the denominator. The denominator can be positive, it can be negative, but it can't be 0. But the numerator itself can be 0. So it allows us to say the range is everything. We're able to obtain everything from this function. You can pick out n number.
For the domain of this same question, how do you write it in interval notation?
In interval notation, you say the domain of f is from negative 2 over 3 included all the way up to 4. So 4 will give us a break there. And then you don't end there, we proceed. So you just skip 4 and keep going to infinity. So you don't include it on both intervals. So we'll be disconnected in a minute because of our Zoom platform. And then we'll rejoin so that we continue with this. So now when we get back, we'll be looking at the discriminant and everything around it and the alpha beta roots. We'll comment on them so that we can keep the record, and then we move forward. So let's do it quickly.